Welcome back to the channel, guys. I hope you guys are doing pretty good. Good to see your smiling face today. So, in today's masterclass, we will be understanding a very important topic of Java, and that particular topic is Java map. Now, if you are someone who is preparing for interview, I am pretty sure that you will be asked on the internal working of map as well as where you have used map in your automation framework. So in this masterclass, guys, we will understand not only the theory of map, but also understand the internal working of map, how it operates. But first, if we haven't met yet, hi, my name is Jatin and I help QA professionals just like you transition from manual to automation testing while saving tons and tons of time. So, without wasting time, guys, let's get started with this masterclass. All right, guys, welcome back to the class and I hope you guys are doing pretty good. So, we are discussing the topic of your maps. Finally, we have reached this particular topic. See, the thing is, whatever we have studied so far, the whole goal over here was to make sure that we understand your object-oriented programming pretty well. Now, even for your maps, we have already seen this particular concept somewhere. Where? In your hash set, right? Hash set internally uses your hash map to maintain the uniqueness of the value. This particular point is very important because in interview, they can ask you what is the internal working of hash set and you should be able to answer this particular point pretty well. That hash set internally uses hash map to maintain the uniqueness of the elements which have been stored over there. Now, over there, we have already seen the internal working of maps. So, in this topic of Map 101, we will again revisit that topic. We will understand the internal working of your map and then we will discuss the important methods which are there in your map interface and how do you use HashMap in a project. All right, that's something that I would like to focus on Map 101. Now, for this particular lecture, I want you guys to have your notebook and your pen along with you. So I'll be writing something down on the board and I want you guys to write it along with me. All right, let's get started. Now, my first question to you guys is, if, let's say, someone asks you, tell me, what are maps in Java? What are you going to say? Yes, take a moment, think about it. What are maps in Java? You can say that maps are basically what? An associative array. Okay, it's an associative array. And inside this particular array, we are going to have an association, a relation between key and value. So it's an associative array where association or relation exist between the key, all right, and the value. Okay. Now, whenever we want to retrieve the value, you have to use the key. Is this part clear? So, if I want to retrieve the value from the map, we need to use the key associated with it. Okay. Now, because we are using the key to retrieve the value from the map, this retrieval operation or what we call as the lookup operation slash retrieval operation in your map happens at fast, not fast, super fast, okay, speed. And you can just say that the performance of the get operation or the lookup operation is what? Is constant. And constant is always going to be written with what? O of 1. Not in uppercase. This is a different thing. Okay, we're talking about the speed. Speed is going to be constant. It's going to be O of 1. Now, what it means over here that it is going to be constant, in simple terms, if I had to explain you, whether your map is going to have 1 record, 10 records, 100 records, 1000 records, or 10,000 records, okay, 1 million records. If I want to retrieve a particular value associated with a key, and if I'm going to give the key and I want to retrieve the value, that operation is going to happen quickly. Is this part clear to everyone? Perfect. This is the advantage of map. Now, in your real world, guys, where do you use map? We have seen those examples, right? Where do you use map? You have seen your Oxford dictionary, right? Yellow pages. Okay. So these are some of the real world example where you might be using your maps. Okay. So understand one thing. Whenever I have a word, let's say I want to search for a word called map in dictionary. Okay. And your dictionary is going to have what? A lot of words over there, like lakhs of words which are there. And still, even though there are lakhs of words, I know that I'm going to search for a map word. How much time it is going to take for me to get to that particular word in dictionary? Okay. Might be 2 minutes, 3 minutes. All right. So the retrieval operation is going to be constant. Same goes with your yellow pages also. If I have to search for a contact number in yellow pages, it does not take a lot of time. Are you getting the point? So that's some of the real world example where maps come into picture. Now, when you're talking about maps in Java, map technically is an interface. Okay. Map is basically what? An interface, and there are going to be different classes which are implementing this interface. Okay. You have your linked, you have your HashMap class coming into picture, which implements your map interface. Then you have your tree map coming into picture, which implements your map interface. Then you have your linked hash map, guys, linked hash map class, which is actually a child class of your hash map, which implements the map interface. Hey, you have seen these particular words somewhere. Hash map, linked hash map, tree map, hash set, linked hash set, tree set. So over here, guys, in your hash map, the order of retrieval, okay, is not maintained. Okay, you cannot predict the order of retrieval because it uses something which is called as hashing to store the elements inside the map. Then you have linked hash map. If I want to maintain the order of insertion, okay, so not order of retrieval, order of insertion is not maintained. In linked hash map, order of insertion is going to be maintained. And in your tree map, what is going to happen? The elements will be printed in sorted order. Is this part clear to everyone? Now, out of these three maps, okay, the performance of hash map is way better compared to the linked hash map and tree map. All right. Now, there are other types of map also, but these three are going to be the prominent one. So in interview, they can sometimes ask, what are the different types of map that you are aware of? So you can just talk about your hash map, linked hash map, and tree map. Okay. Then there is a concurrent hash map. Then there is a weak map. There's so many things which are there, but these are the three prominent ones that you should always remember. All right. Quickly make a note of all these points. All right. I hope you have made the notes for all these things. Let me just delete this thing. Now, what we have understood so far, guys? We have understood that the map is technically an interface. Okay. The next thing that we know that map, this particular interface, guys, is going to help us allow, store an association between a key and a value. All right. Now, because there is going to be an association which is going to be there, lookup, that is the retrieval of value, is going to be super fast. That is going to be O of 1. All right. Meaning whether there is going to be one record, 100 records, 1,000 records, 1,000,000 records, the retrieval is going to happen at a constant pace. Okay. Now, there are going to be three prominent classes which are there in your map. So, one is going to be your hash map. The second one is going to be linked hash map. All right. Which is nothing more than the child class of your hash map. And then you have third one coming into picture, which is going to be your tree map. All right. Hash map doesn't maintain or does not maintain insertion order. Linked hash map is going to maintain the insertion order. And in tree map, the entries will be retrieved, okay, in sorted, or I would say ascending order. Now, one more thing, remember that all these three classes belongs to your java.util package. Is this part clear? All the three entries belongs to java.util package. Now, coming to your hash map, majority of the time whenever you're working in any project, you will end up using HashMap only. Why? Because it uses a special technique which is called as hashing. So, retrieval from HashMap is constant. It is fast compared to your linked HashMap and tree map. So, HashMap uses a special technique called hashing to insert your key and value in the map. Okay. Now you will ask, Jatin, what is hashing? Okay. Or if you're not asking me, the interviewer will ask you, what is hashing? All right. So just remember this thing for now. Hashing is basically a special technique in which a large object, okay, will be converted into a fixed length integer value. I'll repeat it one more time for you guys. Please make a note of this particular stuff. Hashing is basically a technique in which a large object will be converted into a fixed length integer value. And we need to perform hashing to decide the bucket index where the key and value will be stored. All right, where key and value will be stored. If you want to know the exact word, okay, decide the bucket index where the node which is going to consist of the key and value will be stored. Hashing is also used for one special reason, to avoid avoid collision. We'll discuss on all these three things. We have already seen it in set. That's the reason I'm writing it off over here for you guys. But remember, hashing is basically a technique in which a large object will be converted into a fixed length integer value. Basically, with the help of this hashing, whatever the hash code is going to be generated, it is going to help Java understand inside which bucket, the bucket index that needs to be used, where the node, the key and the value will be stored. Okay. And one more reason that we use hashing in your hash map is to avoid collision. Okay. These are the three core reasons of using your hashing. All right. Now let's discuss about this hashing. Okay. How exactly a large object gets converted into a fixed length integer. All right. So let me just delete this particular drawing. Before I delete it, if you want, you can quickly make a notes of all these things, because if you write along with me, what is going to happen? You'll be able to remember all these things better. You don't need to watch the video again, right? So quickly make a notes of all these things. Okay. I hope you have made the notes. Let me just delete this thing, guys. And now let's try to understand hashing. What is hashing? As I said, hashing is basically a technique. It's a technique where we convert a large object into a fixed length integer value. And this int value, my dear friends, we use it as bucket index. Okay, where the node will be stored. And when I say node, I'm talking about your key and value. Now, there are many ways using which hashing can be done. You can create your own hashing algorithm also. So companies pay a lot of money so that, these hashing algorithms can be created. Now, if you don't want to create your own custom hashing algorithm, your Eclipse also does a very decent job. They have those inbuilt hashing methods which you can use, and they will generate the entire hash code for you guys. Now over here, guys, I want to generate the hash code of, let's say, an integer object. This is what I want. I want to generate the hash code of an integer object. So over here, I have written over here integer object. It's not integer I equal to 10. Is this an integer object? No. This is a primitive integer variable or int variable. So if you want to create an integer object, you have to use wrapper class. I will say integer I. I becomes my reference variable. Okay, equal to new integer 10, or you can simply write 10 also. Okay, but because we use classes, right, I'm just giving an example over here that this is my class. I'm creating a reference variable. This becomes my object. Okay, so over here I can directly auto box also. If I put 10 also, Java will still consider it as an integer object. Now, if I ask you, who is the ultimate parent of integer class? Who is the ultimate parent of integer class? Can you answer it off? Do you know? You should know. Parent of all the classes in Java is object. This particular class, guys, has a method called hashcode method. Okay. As the name suggests, it generates the hash code, which basically uses a technique called hashing, which converts a large object into a fixed length of integer. So with the help of hashcode method, I will be getting a fixed length integer value for any object. So over here, if I say I want to get the hash code of integer object, I can say int, or let's say I dot hash code. What will be the answer? Yes, I dot hash code is going to give me what? It's going to give me the hash code of this integer or your object 10 over here. What will be the answer for that? Any integer object, okay, its hash code is the number itself. Is this part clear to everyone? So if I was trying to create an integer object of 30, what will be the hash code? 30 itself. Is this part clear to everyone? Perfect. Can I go ahead? This was my first example. Coming to the second example over here is, let's say I have a string S, and S over here has only A in string format. So this is a string object, okay? I can still use the hash code method. Why? Because who is the parent of string class? Somewhere down the lane it will be object. Object has the hash code method. So I can say S dot hash code. Now for integers, I know that the hash code of an integer object is the number itself. Then for a string S, a string over here which has some characters, over here I just have one character, what will be the hash code? So over here there comes a formula, okay? 31 raised to n minus 1 into the ASCII value of the character. 31 raised to n minus 1 into the ASCII value of that character, where n is the length of the string. What is the length of the string? You'll say 1. So 31 raised to 1 minus 1 into the ASCII of A. ASCII of A, for your convenience, it is going to be 97 into 31. 1 minus 1 is 0. So 31 raised to 0. Any number raised to 0 is 1. So the answer is 31 raised to 0 is 1 into 97, which is going to be 97. Is this part clear to everyone? This is the hash code of your string A, okay, where this is the only character which I have in the string. All right. Now, over here, guys, suppose I was having the string as A, B, C. Then what? What would be the hash code of this particular string? Let me just delete this particular drawing. But before that, if you want to make a note of all these things, you can make it off. Quickly write it down. All right, I hope you have made the notes. Let me just delete this particular chap now. So let's say, guys, we have been given a string S, which is going to have a value as, let's say, ABC. We want to calculate the hash code of ABC. All right. So just understand, no one is going to ask all these things in interviews, just for your understanding purpose, how hash code gets calculated. So over here, guys, for this ABC string, what is going to happen is this particular string will be converted into a character array. This is my first character, this is my second character, this is my third character. This is going to be on the 0th index, first index and second index. Now, previously we were just having one character in string, right? A was there. That's the reason the answer came as 97. So if you ask me for the ASCII values, the ASCII value of A is 97, 98, 99. So in order to calculate the hash code of ABC, the formula goes like this: S of 0 into 31 raised to n minus 1 plus s of 1 into 31 raised to n minus 2, okay, plus s of 2, which is going to be 31 raised to n minus 3. Now, what is s of 0? You will say a into 31 n minus 1. N over here is the length of this particular string. So n over here is 3. There are 3 characters. So n is 3. So 3 minus 1. Then we'll say plus your character b into 31. 31 raised to 3 minus 2. Alright. This is going to be 3 minus 2 plus your character c coming into picture into 31 raised to 3 minus 3. Alright. 3 minus 3. So over here, a is what? 97. The ASCII value is 97. 97 into 31 raised to 2 plus b is what? 98. 98 into 31 raised to 1 plus c is what? 99 into 31 raised to 0, which is going to be 99 into 31 raised to 0 is what? 1 only, plus 98 into 31 plus 97 into 31 square. This is 99 plus this over here. I have already done the calculation, which is going to be 3038, and plus this is 97 into 31 square, which is going to be 93217, and the final value should be 96354. So this will be the hash code of ABC, the string ABC. Alright, so this is how the hash code gets calculated. Now some of you guys might be thinking, Arey Jatin, why 31? Okay, what is so special about 31? We use 31 over here is because 31 is a prime number. Alright. And when you multiply this prime odd number coming into picture, it is going to result into less collisions. Alright. So if I want to store it inside the hash map, I want to have less collisions coming into picture. So over here, the hash code gets generated taking 31 as your base multiplier. Is this part clear? Now, this is the hash code that I'm getting, 96354. Now, if I want to store this particular string as a key in my hash map, okay, the hash code had to be calculated, and this would be the hash code coming into picture, 96354. It is practically impossible to have an array, okay, which can have an index of 96354. All right. So in today's time, I might be able to create an array which can have this particular index, but this is just for a string ABC. Imagine if it's going to be a pretty big name coming into picture, Jatin Sharma, right? So over there, the hash code which is going to come into picture is going to be very, very big. All right. So hash code is basically used to calculate the bucket index. Okay. So there is a further operation that happens which brings down this particular hash code to make sure that we are able to store it inside a proper bucket index. We'll understand that part, but as of now, just understand how exactly your hash code gets calculated. So over here, a large string gets converted into a fixed length index or fixed length integer value. Is this part clear to everyone? Perfect. Great. Now, similar to this, we can also create hash code of our own custom classes. Okay. I can create a hash code of, let's say, employee class object. I can create a hash code of account class object or student class object. How to do all these things? For that, let's go to our Eclipse. Now, guys, what we're going to do is in your Java practice SRC folder, you notice that we have already created com.collections, set, and list. Now, what I'm going to do is I'm going to right click in the SRC and I'm going to create a package. Let's call this particular package as com.collections.map. And inside this particular map package, my dear friends, we will quickly create a class, a normal Pojo class. Let's call this particular Pojo class as employee. All right. You are already aware of how to do all these things. Okay. Now, I'm going to create two instance variable ID. And let's say I'm going to have another variable called, let's say, employee name. Okay. Employee name. Variables created inside the class and is going to be non-static. It is going to be called as instance variable. Instance variable are always going to be marked with private keyword. So this is my private int ID. This is going to be my private string employee name. The next thing that we are supposed to do is we have to initialize the instance variable. Variable initialization or instance variable initialization is going to happen inside which component? Yes, inside which component? Inside your constructor. So just right click over here, go to source, generate a constructor using the fields, generate it off, and just to add a one-line description, I'm going to introduce the toString method. All right, this is a piece of code that we have generated. It's a boilerplate code. So public class employee, it has two instance variable ID and employee name. You have a constructor of employee type, which technically takes two parameters, integer ID and employee name, which is going to initialize your instance variable ID and employee name. So over here, this keyword comes into picture. This keyword is used to differentiate what and what. This keyword is used to differentiate local variable with instance variable when they have same name. What is the purpose of super keyword inside a constructor? The job of the super keyword is used to call the parent class constructor from the child class constructor. Only a constructor can call another constructor. That is called as what? When a constructor calls another constructor, it is called as constructor chaining. So your super keyword is used to do constructor chaining over here. Can I do constructor chaining within the class? Yes. You can do that with the help of this keyword only. This keyword is used at three places. It is used to differentiate local variable with instance variable. It is meant for constructor chaining. And third, it is used to refer to the current object. We have done that in the builder design pattern. Did you remember all those things? Now, what is the purpose of toString method? The job of the toString method is to print a one-line description for the state of the object. State means your values of the instance variable. Is this part clear to everyone? Okay, we have spent the entire Java course understanding all these things. Then what I'm going to do is I'm going to quickly create a class. Okay, let's create a class called your runner class, or I'm going to say employee runner class. All right. And inside this employee runner class, I'm going to have a main method coming into picture. All right. Now, over here, guys, what I do is I'm going to create an employee object. So I'm going to say employee E1 equal to new employee. Let me just import employee. Yep. Wrong employee. My bad. We created the employee runner in wrong package. It should be created in com.collections.map. My bad. All right. Let's minimize this chap. Now coming over here. Now I'm going to say employee E1 equal to new employee. Int ID, I'm going to say ID as 101. Employee name, let's say Jatin. All right. So this is my object. What happens when you create an object? Yes. What happens when you create an object? Three things are going to happen. Class is loaded into the memory. Instance variables are created. Constructor is called. Class is going to be loaded inside which memory? Class loader memory. Instance variable are created inside which memory? Heap memory. Constructor is called. Constructor is a method. It will be executed in your stack memory. Is this part clear to everyone? How do I know that the object will be created in the heap memory? New keyword talks about it. All right. Now I want to see the one-line description of an object. Just say system.out.println E1. All right. E1 over here is a reference variable. It points to the object. Okay. So if I'm going to click on the play button, this is the one-line description of the state of the object, that there is this object is of employee type. ID is 101. Employee name is Jatin. Now what I want over here is I want to calculate the hash code. Okay. So technically what I can do is I can say E1 dot, you'll see I have this hash code method coming into picture. All right, this hash code method, if you look carefully, it returns me integer value. So remember what hash code does? Hash code is basically, or hashing is basically a technique which converts a large object into a fixed length integer value. So over here, if I'm going to go to this hash code method, press Control on your keyboard, go over here. You see, this is the method which is there. And over here, guys, inside this particular method, right now, this object class, okay, we have this particular hash code method which is native. All right. So now, if I'm going to just right click, run as Java application, I'm getting this number 1361960,727. All right. That is basically what the hash code of your employee object is. All right. Let's copy this and I try to create another object reference. Let's call this as E2. And over here, guys, let's say the object is going to be for Ritu. All right. So I'm just going to copy this line, paste it over here. Let's call this E2.hashcode. And if I'm going to click on play button, you see their hash codes are different. Now, the next thing that comes over here is you can really override the hash code also. Meaning I can use my own custom implementation for the hash code generation. So I can just right click in my employee class, okay, right click over here, go to source, and I'm just going to say generate the hash code and equals method. So this is employee name and employee ID. These two fields will be taken to not only generate the hash code, but will also be used to compare whether the two objects are going to be equal or not. So I'm going to click on generate button, and over here you see this method has been overridden and it uses a different method called as a hash method. So over here public int hash code, this is the method. Internally it is calling another method from the objects class. This is an object class. Okay. So objects is going to be another class in Java, and it basically has a utility method. Okay. This method over here is the static method. Okay. Because we are not creating the object of objects class, and we will be passing the employee name and ID. This particular class was actually introduced in Java 7 version. All right. And technically what it does is it just calculates the hash and gives us back. So I'm going to save it. Okay. Let's right click, run as Java application. And now you will see that the hash code which is getting generated is different. All right. So what happens over here, my dear friends, objects.hash employee name and ID, it is computing the hash code with a different formula, and the normal hash code method which comes from the object class, that is going to use a different formula, as simple as that. Okay. So the thing over here is, for the calculation of hash code, it is always better that you go with a formula which reduces into less collision. Okay. So this particular stuff actually does a very decent job over here. But okay, you see that if I bring my cursor over here to objects, you see it's since 1.7. So it has been introduced in Java 7 version. Now, over here, there is always going to be a contract between a hash code and equals method. This is something that you need to remember. Okay, let me write it down. We say that two Java objects or two objects are equal when they have same hash code. Please make a note of this particular point. In Java, we say that two objects are said to be equal. Okay. Here you have the equal method coming into picture. Na? So I can pass another object of employee type and I can say I want to compare E1 dot equals E2. I can compare the two Java objects and we say that the two Java objects are said to be equal when they are going to have same hash code. So along with the same hash code, we also make sure that we also check for the values of the instance variable. All right. These two things are very important. Okay. So whenever we will be doing the comparison also, whether the two Java objects are going to be equal, we also take into consideration the values of the instance variable. So the two objects, we say that they are equal when they have the same hash code value and the values of the instance variable matches. Okay. This is something that you need to remember. Now, over here, guys, if I go back to the employee runner right now, okay, here you can see that I have two objects. Here the employee ID is 101 and name is Jatin. Let's say the employee ID is going to be 102 and name is going to be Ritu. Can you say the two Java objects are equal? No, we cannot say that the two Java objects are equal because they are storing two different information. But if I'm going to have another Java object, let's say the reference over here is going to be E3. Can you say E1 and E3 are equal? Yes. Why? Because they will have the same hash code. If you look carefully, I'm just going to copy this, paste it off over here, and I'm going to introduce E3 also. So we have E1.hashcode, E2.hashcode, E3.hashcode. So if I'm going to save it, click on the play button, notice the two values. The two values, the hash codes are equal over here. So we can also conclude the two Java objects are equal. Along with that, they have the same values for the instance variable. Okay. Now understand something. What is the whole purpose of this hash code and hashing? Okay. These hash code and hashing are basically used in your maps, particularly to decide where the key and the value needs to be stored. Okay. So going back to our board now, let's go back to the board. Let's delete all this particular drawing. And over here, let's open the blackboard. If I have to talk about the internal working of our map, understand something. A map, okay, or a hash map over here basically consists of something which is called as a table. You can call it a table, you can call it an array. And over here, since it's going to be an array, it is going to have a size. The size of this particular table is going to be 16. So this is going to be 0th index. This is going to be first index, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15. Index is going to be 0 to 15. All right. The size of this entire table is going to be 16. Is this part clear? Now, each index basically is called as what? A bucket. Okay, please write it down. Please write it down. So over here, map basically consists of an array. Okay. Sometimes they call it a table also. And this table basically has a size of 16 where each index is basically called as a bucket. And the index ranges from 0 to 15, which is very obvious if the size is going to be 16. Now, let's say I try to create a hash map. All right. I'm going to say hash map. All right. Of, let's take the simplest form, integer, comma, string. Okay. I'm going to call this as HMap equal to new hash map. So when you create an object of hash map, this table gets created. Now, over here, guys, each index on this particular table, which is called as a bucket, can hold a node. And a node is basically what? It is going to consist of certain things. It is going to first consist of int hash, that is the hash code value. Second, it is going to consist of key, the key which you have created. So over here, integer type is going to be my key, and the value is going to be of string type. So I'm just going to say over here as integer. Then you will have value coming into picture. Value v is going to be what you say as string. All right. And one more important thing, guys. There's going to be one more field. It is going to also consist of a reference of the next node. All right. It's going to consist the reference of the next node. So technically, each node which will be stored on this particular bucket is actually going to be a what? Linked list. Is this part making sense to everyone? So a map basically consists of two things. It consists of an array plus linked list. Please make a note of this particular point. Is this part done? Now, how to insert element inside a map? How to insert an element inside a map? Whenever you want to insert an element inside a map, technically you use a method which is called as put method. And put method basically requires two things. It requires key, and the next thing it requires is the value. So over here, let's say that I want to put hmap dot put. Let's say it's going to be integer, right? So I'm going to say 101 and the value is going to be Jatin. Okay. Hmap dot put 101. Okay. Not 101. Let's put 10. Let's make it 10. Okay. So 10, comma, the value is going to be Jatin. So the key has become 10 and the value has become Jatin. So what this put method is going to do is, it's going to calculate the hash of the key. The hash of the key. Now, if you look carefully, this is a number. 10. 10 is a number. So, if I am going to calculate the hash of 10, what is the hash code of 10? What is the hash code of an integer object 10? The value itself 10. All right. It's going to be 10 itself. So, this 10, the hash which got calculated, okay, is talking about the index, where exactly we need to store the node over here, the key and the value, where it is going to be stored. From this entire array, we have to go to the 10th index. All right. And over here, a node will be created. And node is going to have hash. I'm going to say integer hash h. The value of that is 10. Then key. What is the value of key? 10. What is the value? Value is Jatin. And do we have a next node right now? The answer is no. We don't have a next node. So next right now will be null. Is this part clear to everyone? Perfect. So we calculated the hash. We calculated the hash of the key. Key was 10. Hash of 10 is going to be 10. So this 10 which got calculated is actually talking about the bucket index where the node needs to be created. So we got a node which got created over here, and this node has the information that the hash code is 10, key is 10, value is Jatin, and the address to the next node is null, meaning there is no other link node coming into picture in this linked list. Clear? Now, let's say we have added this particular node into the map. Now, I want to add another key value. Okay, so I'm going to say, let's use a different color. Which color? Blue color. Let's take this. I'm going to say HMap dot put. I'm going to say 32, comma, Uday. Now, understand something. Since we are saying that it's going to be a put operation, it needs to be put inside this particular map. So, hash of what will be calculated? Hash of key will be calculated. What is the key? Key is 32. What is the hash of 32? You will say number itself. Now, if I ask you, is there an index? Is there an index called 32 inside this particular array? In this whole array, do you see index number 32 coming into picture? The answer is no. You'll say, array 15. The maximum index right now is 15 only. So, over here, this is not the direct hash that comes into picture. There is a further improvement that happens. So, what your map does is, it tries to bring the number within the range of 0 to 15. So, it is going to use the modulus operator. Okay. So, 32 mod of 16. 32 mod of 16. Mod is always going to give me remainder. So, if I am going to say divide 32 by 16. 16 2s are 32. Modulus is going to give me the remainder. What is the remainder? 0. So, over here guys, directly the number does not becomes the hash code. We have to bring it down into a range of 0 to 15. And for that, we are using the modulus operator. So, now that I got the remainder, this becomes the index of your bucket. So, on the 0th index, my dear friends, a node will be created. And this particular node, guys, is going to have a lot of information that the hash of this particular key and value, which is 0. Hash is 0. Your key, what was the key? Key is 32. What is the value? You will say Uday. And do I have a next node right now? So, next right now is null. Is this part making sense to everyone? Perfect. So, please remember that there is going to be a further improvement that is done. Okay. Now, one more important thing, guys. In order to make this particular operation really fast, Java does not use this modulus operator. All right. It uses a bitwise operator. Okay. So, it will be the hash ampersand n minus 1, where n is the size of the array. So, it is going to be 32 your ampersand 15, 16 minus 1, which is going to be 15. This particular operation is going to happen. It is also going to give you the same remainder only. But over here, this operation will be fast because bitwise operations are fast in compared to your mathematical operation. Is this part making sense to everyone? Perfect. Now guys, just to reiterate whatever we have discussed so far. See, when you're talking about a map, Map basically consists of two things. What? It is a combination of your array, that is a table, and the next thing that it is going to have, it's going to have a linked list. So if someone says what is a map, internally map uses array and a linked list. The map is basically, or the array is basically called as a table, and this table is going to be of size 16. All right. Now, when I say size is going to be 16, it's going to be having index from 0 to 15. Is this part clear? On each of this index, I can actually store a node. Now, what is this node? A node is going to be a special class, okay? And this node class basically store four things. It stores the hash, all right? The next thing that it stores is going to be key, the value, and the address to the next node. So the node which we are trying to create, okay, on each of these bucket is actually going to be a linked list. All right. So when we try to perform a HashMap.put operation or a map.put operation, I need to pass two things. I need to give the key, and the next thing that I'm supposed to give is the value. Now, since I have created a hash map that can store integer and a string, that is, the key is going to be of integer type and the value is going to be of string type. Look over here, I am putting 10, comma Jatin. 10 is going to be integer kind of object, and Jatin over here is a string kind of an object or a string value coming into picture. Now, the moment I am going to say go and put this particular key and value inside this particular array, how it works is, the first thing is the hash of key will be calculated. The hash of key will be calculated, that is hash of 10. What is hash of 10? 10. Then what it is going to do is, in order to fit this hash between 0 to 15, between the size of 16, right? What it is going to do is, it is going to say, take that particular hash and calculate the modulus with respect to 16. Okay, that is, give me the remainder over here. So 10 modulus 16, if I divide 10 by 16, 16 zeros are, and you will notice that if the number is going to be less than the divisible, okay, then it is going to be the same number. So if 10, we try to divide it by 16, it is a smaller number compared to 16. The answer is going to be, the remainder is going to be the number itself. Okay, if you try to divide 1 by 16, the answer is going to be what? 1 itself, the number itself. Okay, and just to make sure that this modulus operation is going to be fast, what Java does is, it uses your bitwise operation. All right, so it uses your bitwise AND operation coming into picture. Now you will be thinking, why exactly I need to do this hash modulus 16, right? Why do I need to bring now the number between the range of 0 to 15? And the answer to that particular question, guys, is just a moment back I showed you the employee object. Employee object was having the hash code like in lakhs, right? Or probably in 20 lakhs or something. So you cannot have an index which is going to be of 20 lakh, right? We need to bring it down to something which can fit within this particular range. That's the reason we do hash modulus 16, or I would say hash ampersand your bitwise and n minus 1, that is 16 minus 1, that is 15. So hash bitwise and 15. Okay, so that's how the entries are getting stored over here. Now guys, let's try to add two more elements inside the hash map. So I'm running out of space. Let me just rub something over here. I hope this particular part is clear to everyone. I can rub it off over here. All right, let's rub these things. Okay. And this is also fine. What else I can rub? I can rub these things. Okay. Now, observe carefully. I'm going to say HMap. This is the third entry that we are trying to do. HMap.put. Let's say I'm trying to say that the key is going to be 26 and value is going to be, let's say, Kajal. So the hash of 26 will be calculated, which is the number itself 26. Then we will try to fit 26 within the range of 0 to 15. So we're going to say modulus of 16. So 16 should be used to divide 26. 16 ones are 16. And you will see that the remainder that turns out over here is 10. All right. So this bucket number 10 will be used to create a node. But if you notice carefully, there is already a node which is present over here. So if Java tries to go and create a node on bucket number 10, it is going to result into something which is called as collision. What? Because there is already an entry, there is already a node which is present, so we are having a collision. This collision basically results into creation of a linked list. So now a linked list of node will be created. So over here, all the nodes which are going to have the hash as 10, which will be stored over here, then we are going to say that the key was 26. Okay. And the value over here was Kajal. And whatever is the reference, or let's say the address of this particular node, okay, it will be updated over here. So that's how a linked list gets created. Okay. Now, whenever you want to retrieve a value from this particular map, all you are going to say is HashMap dot get me the value, and for that value you're supposed to go and pass your key. So I'm going to say that get me the value, okay, of the key 26. So out of all the entries which are there inside this particular array, okay, 26 comes into picture, right? So the first thing is it's going to calculate the hash of 26, which is going to be 26 itself. Then 26 modulus 16 will happen. It's going to give me the answer as 10. It knows that it has to go to the bucket number 10, and from here it is going to do a quick traversing and it's going to check whether the key is going to be 26 or not. So not this one, it's going to go to the next one and it's going to take this particular stuff, what is the value Kajal, and Kajal will be written back to the user. Is this part clear to everyone? Perfect. This is how the working happens inside your HashMap. Okay. Now, there is one more thing that you are supposed to remember. See, having this particular collision is actually not a good thing. Okay, because what is going to happen if too many collision keeps on happening, the linked list is going to be pretty big. So what Java has done over here is, or I will say what was introduced in Java 8. In Java 8, the threshold of your linked list in your map is of 8. All right, is of 8. So if your entire linked list is going to have 8 elements inside it, it is then going to be converted by Java into a balancing tree. Just remember this particular stuff, because when you're using a balancing tree, your retrieval is going to be faster compared to that of a linked list. Okay, so it uses something which is called as a red-black tree. Okay, that's what it is used over there. Now, one more thing over here to remember is, like, if you have seen array list, you have seen vector, the concept of capacity was there. Array list is going to increase the capacity by 50%. Vector increases the capacity by doubling it. Okay. So over here in your map, guys, we don't have the concept of capacity, but we have something which is called as a load factor. All right. And the load factor in your HashMap is going to be 0.75, meaning when your array, this table, is 75% full, meaning there are certain buckets which have got created over here, then the array size will be increased by doubling it. Meaning, right now, what is the size of this particular array? You will say 16. So when 75% of this particular array is full, that is actually going to be 12 buckets are full, what is going to happen is you will be given a new array of size 32. Of size 32. And over there, all the elements which are there, for them, rehashing is going to happen. Rehashing basically means, if you remember, we were doing 32 ampersand 15 because he assumed the size of the array was 16. Now, when the array is going to be 75% full, then your rehashing is going to happen because the size of the new array is going to be 32. So over here, you will say 32. Let's say if this is the hashing that I need to do, 32 ampersand 31. So rehashing of all the nodes are going to happen, and that is going to be time consuming. So whenever there is going to be a resize of hash map that happens, it's actually not a good thing. The reason for that is all the buckets, or I will say all the nodes in the buckets, they will be rearranged. And that is going to be something which is going to cost you some performance issues. Is this part clear? Perfect. So that's the entire theory of your hash map. All right. I hope this particular part is clear to everyone. Now, what we are going to do, guys, is we are going to go to our Eclipse and we will practice on creating hash map. We will try to see how to traverse over hash map. What are the different methods which are there inside the hash map? But before that, like this was a very exhaustive theory class that we were having. I want you guys to take a 5 minutes break. Okay, we'll have to do it today itself. Okay, so take a 5 minutes break, just freshen up. Okay, and come back, and then we'll start writing the code together. Clear? Take a 5 minutes break. I hope you have understood whatever we have studied so far, guys. Now, there's also going to be a second part of this particular masterclass, which I'm going to keep it exclusive for our YouTube Tech with Jatin members. If you're interested in studying that, I will highly recommend you join our membership. The link will be in the description section of this particular video. Now, for a price less than 100 rupees a month, you're going to find detailed lectures like this. Along with that, you're going to find important SDET coding assignments, which have been asked in a lot of product-based companies. So if you are serious of preparing for your SDET interviews, this membership is nothing more than a gold mine. All right. So I hope to see you guys over there. And even if you don't join it, it's completely fine. I'm going to see you guys in some other public video. Till then, take care. Bye-bye.